Good afternoon all of you, and here is an ISI paper, and I hope you have written the exam well. So this is a subjective problems. Objective problems were also okay. It's not much difficult. So now find with proof all possible value of t such that this equals c, where for some real number c also find corresponding value. So this was also an easy problem because you can convert this problem as sigma r to the power 1 by 3. R is running from 1 to n. So that will demands basically r by n to the power 1 by 3, a typical problem from integration which connects integral as limit of sum. So r by n to the power 3 by 2, that demands clearly n to the power 1 by 3, and we have 1 by n, so we have divided by n by t. Now this part we can evaluate, because if you just check this part, so this sigma r by n to power 1 by 3 1 by n, r is 1 from n, limit n tends to infinity, this quantity can be evaluated just as x to the power 1 by 3 dx. R1 corresponds to 0, Rn corresponds to 1, and that goes to x to the power 4 by 3 into 3 by 4, which gives 3 by 4 as the calculations. So now we know the given limit can be written as 3 by 4 times n to the power 1 by 3 minus t. We were having extra n, so that will be plus 1. So it's 3 by 4 n to the power 4 by 3 minus t. Just check one's calculation. Now limit n tends to infinity. I am able to separate this into two parts, by the way, because limit of this part exists, hence I am allowed to do that. So it will become infinity to the power 4 by 3 minus t, which will clearly goes to infinity if like t will be less than 4 by 3. If t is more than 4 by 3, then let's say infinity to the power something will get like say minus 1, minus 2, minus 3, then it will go to 1 by infinity, which is tending to 0. Okay, so then the value of c is either going to infinity or tending to 0, but we want for some real c should be greater than 0. Okay, so for positive value of c, and also find corresponding values of c. So one possibility is if I'll give t exactly 4 by 3, so in that case we have 4 by 3 minus t becomes 0, so limit is finite, and corresponding to this the answer is 3 by 4, right? The other case, if I'll consider t as anything which is more than 4 by 3, then the limiting value of this expression, the limit value of this expression will go to 0. So that is not accepted in our case because we want the limit to be strictly positive. Okay, so this was an easy problem. Let's move to the next problem. Consider a polynomial q and x equals this, so that the equation has only two real roots, namely 0 and 1. So there are many ways of solving this problem. One way is you could operate using induction also. You solve for qk and then transfer the information to qk plus 1, provided it starts with the base case of n equals 2. The other way is you can observe qn x equals qn 1 minus x, the symmetricity of this expression. Okay, so with these observations also we know, let's say the value at x equal to 0, we can clearly say 0. Similarly at x equals 1, it's 1. And we know the situation is completely symmetric about 0 and 1, because we know qn half will be qn half. So if I'll replace x with, let's say, half plus x, that will give qn half plus x equals qn half minus x. And that's a good news. It means I know the function is strictly symmetric about x equals half. So now let's suppose if we have more than two real roots, so we can have even this situation, or we can have situations like this, they're still having symmetricity, right? So if this equation will have more than two real roots, so for every real root alpha, which is between 0 to half, we have in the root its image half plus alpha. So for every we have alpha bar, which is also there. Okay, so the number of roots of its qn of this polynomial has to occur in even number, right, until q of half is the root, which is clearly not here. And that's not very surprising to contradict, because you can clearly see, like if you keep on differentiating, you'll get information about q and s. So that's one way of solving the problem, right? And from there you can deduce. The other way of doing this is you can even start of integrating q and x, and let's define f of n of x is integral of q n of x, okay, in dx, and plus some lambda, and on that f and x you apply Rolle's theorem and try to establish like you can't have more than those real root. Still we have a third simple solution of this problem. So method 3 will be directly differentiate qn. So qn dash x is gonna be minus nxn minus 1 plus n into 1 minus x n minus 1. So we can take n common and we'll have 1 minus x to the power n minus 1 minus x to the power n minus 1. And from here the critical point is only x equals half. So more than half we can see it will be negative, and less than half it's positive. So the function is increasing from 0 to half, right, and function is decreasing from half to infinity. तो ये तो function strictly increasing हो गया from minus infinity to here, right, and the function is decreasing from half to infinity because we have only one critical point. And half, it's not difficult to see the value of the function will be positive. How? Because if I'll keep x equals half, I'll get 1 minus half to the power n into 2. Now since n is more than equal to 2, so this value at n equals 2 is going to be 0. Okay. For n greater than 2, this will always be a fraction. Let's say 1 minus 1 by 4 into 2. So this is fraction. So 1 minus fraction will strictly be positive. Okay. So with this logic, this problem can be killed in many possible ways. So again, I'll write this an easy problem. For question 3, again, you have delta 1, delta 2, delta 3, and delta 4. So what you can do is, we could have just connected this with angle theta of pi minus t minus delta. And in this triangle, if you'll apply basic sine rule, and you can connect these angles, so directly it gives this proof. Question 4 is again a standard questions. So you could have done g dash 0. You could have started with, in the definition of derivative, so it's g of h minus g of 0 by h limit h tends to 0, right? Now what is g of h? According to the functional definition, fh sine of 1 by h minus g0 is 0 divided by h. So now the question is, g is also differentiable at 0, it means this limit exists, right? If this limit exists, so limit h tends to 0, this quantity exists. Then we have to prove that g dash 0 must be f dash 0, that must be f0 and g0, and all should be 0. One thing is very obvious, when h is tending to 0, you know this quantity will go to sine of plus minus infinity. So anyway, that's a finite value, dancing limit from minus 1 to 1. So we want something dancing from minus 1 to 1 times f of h by h to exist. Okay, g is also differentiable, means this should exist from both. Since the denominator is tending to 0, and we know this is minus 1 to 1 multiplied by f of h, so clearly f of h must also be 0. Okay, it means limit h tends to 0, f of h must be 0, and that forces f0 to be 0, because if this limit exists, if limit h tends to 0, f of h is not 0, then we'll get something non-zero value divided by 0, and that will definitely be non-existent limit. तो यहाँ से तो ये part is broken, f of 0. Once fh by h exists, once f of h by h exists, since function f is differentiable at 0, already given. So basically this is nothing but it's derivative of f dash 0, because I can write fh as what? Since I proved f0 is 0, so f of h minus f of 0 by h minus 0, limit h tends to 0, and that's fundamentally f dash 0. So that captures the feeling of f dash 0 should also be 0. Right. Now if f dash 0 is 0, so that automatically makes this derivative 0. It means that forces g dash g to be 0. And clearly g dash 0 to be 0, g of 0 is automatically there because from the functional definition. तो ये भी साधारण सा क्वेश्चन था बेसिक पे. Fifth question is also interesting and easy. See, p of x you can write as, since alpha 1 to alpha k with a distinct real root, so it can be written as lambda times x minus alpha 1 to x minus alpha 2, x minus alpha 3 till x minus alpha k. Now p dash is a derivative of p, then so that this. So what you can do is basically you can directly take derivative, or first you can take mod on both sides and then take log. So limit x alpha, and this is ri for some positive integer. So what it is telling, let's say limit x tends to alpha 1, x minus alpha 1 times p dash x divided by p of x is giving you r1. Means this limit is finite for some positive integer, and this exists, and it's basically, you know, it will give some finite integer r1. तो अब यहाँ से what we can do is we can find p dash x. p dash x में क्या होगा, फर्स्ट बॉक्स को डिफ्रेंशिएट करेंगे, बाकी सब को छोड़ेंगे, ठीक है. तो ये हो जाएगा, सपोज फॉर द सेक ऑफ सिंप्लिसिटी आई एम टेकिंग लैम्डा एज 1 बिकॉज एनी वे लैम्डा विल कैंसिल इन पी डैश इन पी ऑफ एक्स. So x minus alpha 1 differentiation will be 1. So we will get x minus alpha 2 till x minus alpha k. Similarly, plus you will get x minus alpha 1, alpha 3 is missing, alpha 2 is missing, and so on and so forth. So this can be written as simply 1 by, you know, 1 by x minus alpha 1 plus 1 by x minus alpha 2 till 1 by x minus alpha k times px. So that is basically what we are getting for p dash x. अब यहाँ से p dash x by p of x आप clearly वहाँ से लिख सकते हो, and then take limit x minus alpha, limit x tends to 0, ठीक है. So here what you can do is either you can use logarithmic differentiation or directly you can calculate. So that will give you answer. Let's move to the next question. And question number 6, I feel like was the technical question among all this. x1 till x 2024 be non-negative real numbers. Non-negative means x1 is either greater than equal to 0, so is x2, and so on so forth till x 2024. Find with proof the minimum maximum possible value of the expression x1 plus x2 till x 1012 plus x 1013 whole square till x 2024 whole square. Now clearly you can see like they have copied this from some sources where the generalized problem was not 2024 but it was till 2n. So the generalized problem could be sigma xi I equals 1 to n plus sigma xi whole square where I is running from n plus 1 to 2n. अब 2n के n के जगह पे they have simply kept 2024, but 1012 they have kept actually to create this problem. Okay, so one idea was to just start with the smaller case and possibly you can push forward the idea with mathematical induction. The other method will be, which is not in syllabus for ISI at UG level at least, is you can take the entire function as some function which is of multi-valuable x1 to x24, and then you use a partial derivative del phi by del x1, del phi by del x2. Okay, make it 0 for minimum maximum, and accordingly you'll get all the points. So that analysis is not in our syllabus for UG. So I'll give you a very simpler logic of doing this. Okay, so what we can do is, you see, finding maximum value is not difficult because I know any value since xi is greater than equal to 0 and the sum of them is 1. That's very important. It means if I'll add all of them, x1 plus x2 till x 2024, that's gonna give me 1 as the answer. तो यहाँ से हम क्या बोल सकते हैं, अगर मैं x1 लूँ और उसका स्क्वायर लूँ एन x1, so which will be more? Clearly all these xi must be fraction because they are non-negative and they are adding to 1. So x1 square will definitely be less than x1. Similarly x2 square will be less than x2 and so on. So I know this entire quantity will definitely be, this will definitely be lesser than sigma xi I is running from 1013 to 2024. So it means this plus this is definitely less than equal to sigma all xi I is running from 1 to 2024, and this summation is already 1. So we got the answer for maximum value is clearly 1. So we got the answer for maximum value is clearly 1, and which is achieved when xi square is equal to xi. अब एक्स वाई स्क्वायर इक्वल टू एक्स मीन्स एक्स आई आइदर 0 हो जाएंगे और 1 हो जाएंगे. ठीक है, कहाँ से कहाँ तक? फ्रॉम 13 to 2024. So there are many combinations where under which we'll get the maximum possible values. For example, one of the such possible values is all xi from 1 to 1012 is 0, 0, 0, and all from there onwards is basically their summation is, and just one of them is actually 1, right? Except let's say x 2024 is 1. So under this condition, all is 0 except 1 will give me 1 as the maximum possibilities value. There can be many other situations like this. The more interesting and little bit technical case is to find the minimum one. So here we'll have a very slightly different approach, and the approach goes like this. Let's say the second part of this summation. Okay, let's say if I define x 1013 to x 2024, and this summation I define as some real number t. So clearly t is lying from 0 to 1 according to problem statement. Okay, now what is sigma xi from 1 to 1012? So that will become 1 minus t, because 1 is a total summation till 2024. So this is nothing but 1 minus t. So now question is 1 minus t plus sigma xi whole square from 1013, I is running from 2024. अब देखो, now we can put a bond here, क्योंकि ये जो सिग्मा एक्स आई स्क्वायर है ये एक फील दे रहा है वेरिएंस का. अब देखो अचानक हम वेरिएंस का फील क्यों ला रहे हैं? बिकॉज आई नो दिस मीन सम स्क्वायर इनइक्वालिटी इज नॉट देयर इन जेई सिलेबस. So let's solve this paper from JEE perspective. So variance of number x1 till let's say xk, ये क्या होगा? Mean of a square minus square of. Now you know variance is always non-negative, so mean of a square will always be greater than equal to square of mean. तो वहाँ से जो मेरा inequality आ गया, तो I can tell x 1013 whole square plus blah blah till x 2024 whole square divided by number of objects here. So how many terms are there? इस 1012 से 1 से 12, so इस 1012 terms are there, right? It will definitely be greater than its mean. So x 1013 till x 2024 by 1012 whole square. I hope till here it's very obvious. So this quantity is already known because I know this quantity, the given quantity is t, right? So this will be greater than or equal to t by 1012 whole square. So we shows this sum of a square will be greater than or equal to t a square by 1012. तो ये अपने पास आ गया एक्सप्रेशन. सो नाउ वी हैव 1 minus t. So this entire expression will be greater than or equal to 1 minus t plus t a square by 1012. And remember, t is dancing from 0 to 1. So clearly I can tell now this quantity will be greater than or equal to what? This will be greater than or equal to 1 by 1012. देखो क्यों? क्योंकि यहाँ पे the minimum value will come at what value? The minimum value will come when 2t, let's differentiate, make it 0, when 2t by 1012 equals 1. It means t will become 1012 by 2. So that's not possible because the minimum value of this quadratic expression is coming at a point which is crossing the window of 0 to 1. तो देखो 0 to 1 में ये function कैसा था? Minimum value is coming at some positive. It's coming long after that. Minimum. So I know the function is strictly decreasing in the interval of 0 to 1. Right. So since it's strictly decreasing, the minimum value will come at t equal to 1. और t equal to 1 पे जो इसका आंसर आ गया वो आ जाएगा 1 by 1012. So the correct answer for this question is maximum value is 1, maximum value is 1 and minimum is 1 by 1012. So in general, those who wants to get the answer for this generalized problem which I posed in the beginning, ये वाला, इसका maximum value will still be 1 and minimum value will be 1 by n. Okay. Now at what condition minimum is achieved? So minimum is achieved when all these xi, let's say one of the conditions of getting minimum is when all these xi becomes 0, 1 to 1012 पे ये सब 0 0 0 हो गया और remaining all of them are equal and they are equal to, वो आप calculate कर लो, okay, 1 by 1012, 1 by 1012 करके. That also makes sense because to get minimum value we know sigma xi square is lesser than sigma xi. So if I'll be greedy, I want to kill this as much as possible. So maybe the first term if I'll make 0 and the second term will definitely be lesser than the first expression. Like out of these two boxes, the second box will be lesser than the first. So let's be extremely greedy to kill the first one. And the second one what we'll do is we can try to minimize. अब वहाँ पे अगर मैं ये अरिथमेटिक मीन ऑफ स्क्वायर एंड स्क्वायर ऑफ अरिथमेटिक मीन का अरिथमेटिक नंबर्स का अगर मैं कॉन्सेप्ट दिखाऊँ तो फिर उससे सब इक्वल पे मिनिमम आ जाएगा. लेकिन दिस वाज अ रिग्रेस प्रूफ. Okay, question number 7 was an easier question, basic from application of derivative. Volume is nothing but, you know, like if you have a circular cross section, so if the area is pi r square and height is h, so volume is pi r square inverse, and that's what is mentioned there. So you just take a small element as shown in this diagram and just integrate from the particular element. A sports tournament may just still it's fine, but it was again a good question. I urge you to solve it using the idea is first you play with n equals maybe 2 and n equals 3 and then try to find a pattern. Or you can use principle of mathematical induction because they have already used given you this. So it will be a technical induction, you know, like logic, but it can be done in a nice way. So if you have not done this question 8 and if you want again detailed solutions, please do comment in the comment box. So I hope you must have enjoyed this paper and understood, and I have solved all the problems of the subjective. There was in fact one more beautiful problem from objective, so which just quickly let me go through. It was very beautiful because e to the power x sin x is log x plus e ka power root x plus 2, and they want a number of solutions. So what I can think is e ka power x sin x and minus log x minus e ka power root x is equals to, you know, at x is tending to 0, this quantity will die, and x tends to 0, it will go to infinity, minus 1 something. That you can't define it in negative, so that's good. Now because of e to the power x term, e to the power x will grow very fast than log x, right? Because e ka power x by log x, x tends to infinity is 0. So I know every time x increases, e ka power x will increase, but the problem is like it will try to, sin x will try to pull you down. So e ka power x graph will be something like this, minus e ka power x will be this, and because of sin x, you know, like some kind of behavior will come here. So overall, like mostly infinity, and maybe it might not be in negative sense, so something like these graphs will come. Okay, so when x equals to, clearly there is infinitely many solutions, so इसका आंसर तो infinitely many आ जाएगा. But if you have better way of doing this apart from this fundamental logic, maybe what you can do is you can take the new function this minus this equals psi of x, use derivative, but you have to do 2 to 3 layers of derivative to come to any conclusion. Other approach can be probably you can do approximation of Taylor series of sin x or log x to certain terms and then to manipulate, right? So these are the basic ways in which you could start the question. Similarly, number of elements in the set was also nice, but what you can see is x, if I'll take out, so mod 1 minus x4 is mod of x4 minus x5 is there, right? So, and this is quite cool. This is cool in the sense like this can be written as mod x4 into 1 minus x divided by 1 minus x4. So it's 1 minus x times 1 plus x square plus x cube and blah blah blah. Now either x is 1, like clearly x equal to 0 is a solution, so that I have missed when I'm dividing it. X equal to 1 is clearly a solution. So if it is not 0 1, then mod of x4 by that equals 1, and that's easier to graph because you can define this new functions, or mod x4 equals mod of 1 plus x square plus x cube. So now you can take two cases, either this equals x4 or this equals minus x4, and investigate. So from there you will get again solutions of this equations, right? So I hope you must have enjoyed this paper discussions, and the intention was to give you exposure even for the upcoming JEE Advanced examination, so as you can connect the basic idea.